Hello everyone, my name is Devashish Roy. I'm the head of training and development at the Indian Cybersecurity Solutions, and I welcome you all to this special webinar today. And today's topic is a very important one for the Cisco CCNA and CCNP enterprise, that is STP, Spanning Tree Protocol, RSTP, Rapid Spanning Tree Protocol, and as well as MST, Multiple Spanning Tree Protocol. What is those, and what about the design and troubleshooting those protocols? So let's begin. So we'll discuss about the STP, RSTP, MST, what are the design and troubleshooting part, and we'll also go in-depth exploration of spanning tree protocols, including design considerations and troubleshooting strategies. So what is a spanning tree protocol? So spanning tree protocol is used to avoid, not to prevent, but to avoid the switching loop. So if two or more switches are connected by redundant connections, definitely there is a possibility of a switching loop. So we need to have the spanning tree protocol to avoid that. So spanning tree protocol, rapid spanning tree protocol, multiple spanning tree protocol, these all are essential in network design to prevent loops and to ensure efficient data flow. Because if there are multiple redundant links, so definitely the switches are connected to both sides, and definitely the data flow will be like a loop, like from one source the data will come to other switch, that switch will forward it to the other switch, and then it will go back to the source. So this is very harmful for your network, because the network traffic will increase, and with the volume of traffic or the large volume of traffic, your bandwidth will be very slow. So it is crucial for troubleshooting network issues and optimizing performance in modern networks. So definitely we have to configure STP, RSTP or MST. Now STP actually we cannot configure because it is predefined, it is by default implemented, but RSTP and MST we can configure. So first of all, we need to understand the spanning tree protocol or the STP. STP is a crucial network protocol designed to maintain a loop-free network within the Ethernet networks. So all these technologies like the twisted pair cables, mainly we call it the Ethernet. By preventing loops, STP safeguards against broadcast storms, means all the broadcast traffic is flowing again and again throughout the links. It prevents that because it can disrupt the network traffic. So you have to ensure stable and reliable data transmission. Now, what are the key features of the STP? It is loop prevention. STP effectively prevents network loops by actually determining a single active path between the switches. So redundant paths are no longer supported. We do not support any redundant path, only one active path is supported. And it ensures that data packets do not circulate endlessly, which could lead to broadcast storms and network failures. Then redundant paths, STP provides redundancy by creating alternative paths between switches, now allowing the network to reroute traffic in the event of a link failure. So that is good, but that is also welcoming a switching loop like situation. But if you are not having any redundant path, only you are having single point of failure. So if that link goes down, everything is down. So actually the redundant paths enhances the resilience of network infrastructure. Then what is bridge protocol data units? That is very important in this switch, BPDU. BPDUs are crucial for STP operation, and they carry information about the network topology and their exchange between switches actually to maintain the current state of the spanning tree. BPDU contains many things, like BPDU contains the switch or bridge MAC address, the priority. By default, every Cisco switches have the priority of 32,768. That is the 32768. So it contains all of those informations. Now, what are the limitations of STP? First of all, slow convergence. STP's convergence time can be significantly delayed during network changes. Yes, there are some timers, like to move from the blocking to listening state, it has 20-second maximum age. Then listening to learning, so to learn the MAC address, it has 15 seconds of forward delay, and learning to forwarding again 15 seconds. So 20, 15 and 15, almost 50 seconds it has. This delay can lead to temporary outages or degraded performance. So STP The traditional STP 802.1d or the common STP CST is not so fast and it is not optimum. Inefficient resource utilization. In STP, certain links may be placed in a blocking state to prevent loops, and it results in underutilization of available bandwidth. So some links will be blocked. So this can lead to suboptimal network performance. Also, scalability issues. As networks grow, STP's limitation become more pronounced because with increased number of switches and links, the protocol can struggle because definitely is not so scalable. It cannot support a large volume of switches or PCs. So the convergence times will also be longer. Then we came up with rapid spanning tree protocol. Because rapid spanning protocol was rapid, means it didn't take 50 seconds to converge. Actually, the convergence time was pretty low, 5 to 6 seconds. So RSTP is an evolution of the original spanning tree protocol STP, and the specification of RSTP was 802.1w. And by implementing new mechanisms for faster fault detection and recovery, RSTP significantly improves network reliability and optimizes the use of network resource. So gone are the days where STP were very slow in actually converging the links. This RSTP was very fast. But one thing is there that RSTP you need to configure. It is not like the STP by default. Now, what are the key features of RSTP? Faster convergence. RSTP significantly enhances the speed at which a network can recover from failure and allowing for near instantaneous convergence. So instantly it is actually converging. This improvement is crucial for maintaining network stability and performance. Then port roles, if I tell you, RSTP defines new port roles such as alternate and backup port. Now alternate port is there like an alternate port of the root port, and backup port is something that is rarely used. Because backup port, I can tell you, if say for example two links are connected to the same hub, but gone are the days where you have the hub, but if you have the hub, then those ports are backup ports. But definitely it enhances network efficiency and management. These roles allow better identification of paths and facilitate quicker failover process. Now backward compatibility. RSTP incorporates backward compatibility for STP, so it actually coexists with the STP, allows it to coexist with legacy devices while still improving overall network performance. And this compatibility is essential for organizations who want to transition to RSTP. So they do not need to replace the existing infrastructure, but they can transition. Then what are the advantages of RSTP over STP? Faster recovery times, improved network efficiency, better VLAN management, reduce convergence delays, and enhance fault tolerance. So all of these are advantages of RSTP over STP. Then you come to the multiple spanning tree MST protocol. MST is there for the mainly for the CCNP and CCIE certifications. This is you can say this is the largest form of STP we have. And in MST, we create the instances. You create the instances in the MST. You create VLANs and you map VLANs to specific instances. So MST is designed to enhance network efficiency by allowing multiple VLANs to share a single spanning tree that I've already told you. And it reduces the complexity of managing individual trees for each VLAN, like per VLAN spanning tree or PVST plus, RPVST. These things were replaced by MST. This approach not only conserves bandwidth but also simplifies network topology. So what are the key features of MST? First of all, VLAN mapping. MST allows for the mapping of multiple VLANs to a single spanning tree instances, which maximizes the utilization of network resources by reducing the number of spanning tree instances. So spanning tree instances are less, but in case of the RSTP, like per VLAN spanning tree, you are having one instance per VLAN. So that is definitely a lot of burden. Reduce complexity by consolidating multiple VLANs into fewer spanning trees. Now MST can reduce the overall complexity of network management and is a simplified protocol. This simplification can lead to easier troubleshooting and more efficient process. Next, the improved load balancing also. MST enhances load balancing by allowing traffic from several VLANs to share the same physical link. So definitely it achieves load balancing. This results in a more balanced distribution of network traffic and prevent congestion or bottleneck. So what are the advantages of MST over RSTP? Resource optimization is realized, efficient VLAN usage is achieved, streamlined management, easier to configure, improved load distribution means balanced traffic flow across the links, scalability means supports larger network effectively, and enhanced performance means optimized response times. So these are the advantages we have over RSTP, the MST has. So what is the design considerations for STP, RSTP and MST? First is network size consideration. The scale of the network depends which protocol you have to use, which type of spanning tree, STP, RSTP or MST. Larger networks may require more advanced configurations like MST or RSTP, but very little devices, say a small network, will actually work with STP only. Importance of redundancy. So you have to incorporate redundancy in network design to enhance reliability, and it is essential to plan for backup paths that can be utilized in case of link failure. So you have to simulate the link failure. You have to know that this link may fail, and you have to incorporate the redundancy there. Then VLAN configuration. Proper VLAN configuration is crucial for optimizing the network performance. Now, ensuring that VLANs are accurately mapped to the spanning tree, it allows for efficient data transmission. So you have to map the VLAN to the spanning tree protocol accurately. Now, common troubleshooting techniques means if you are having any such trouble in the, say, the spanning tree protocol, say between the switches, you have to capture the BPDU, you have to do the BPDU transmission analysis, you have to read the BPDU data. If some fields are actually not matching, or say the revision number is not matching, all these things can happen. So you have to analyze that. Port states verification, if all ports are in forwarding or blocking state, some ports, that you have to do. Also topology loop analysis. So these things you have to do. Now what are the case studies for STP, RSTP and MSTP issues? Case study 1, that a significant loop issue occurred in a network using STP, causing packet loss. So root cause was traced to improper switch configuration that I was telling you, leading to redundant paths that STP could not manage effectively. So redundant paths, you have to figure it out and you have to resolve the issue. Case study 2 was in a large enterprise network, RSTP experienced significant convergence delays following a topology change. So it may happen. This was investigated and found to be due to misconfigured port roles. So if you have misconfigured ports, that definitely the root port or the blocking port issue will happen. The fix involved re-evaluating and updating port configurations to ensure optimal performance. Case study 3 means an MST implementation faced VLAN mapping errors that resulted in uneven traffic distribution across the network. So if you are actually inserting the VLANs into wrong instances, for example, definitely that would be disaster. The diagnosis revealed incorrect VLAN assignments that I've already told you, which were corrected by reconfiguring the mapping settings, and it improved the load balancing and simplified the network management significantly. So these are the common troubleshooting techniques also that I have discussed with you. So you can say that this is a theory part behind the STP, RSTP, MST. And let me take you to the console of the packet tracer. And here we'll configure the STP, RSTP. So you have these switches. So I'm taking 3 switches. I'm connecting with the fast Ethernet. Here also the fast Ethernet, but this side I'm using gig port, gigabit. So the path cost will be lower across this gig path, and I want to make switch 0 as the root bridge. So I have to lower the switch priority. So go to the CLI, spanning tree, VLAN 1, priority, and what are the values you have? In increments of 4096 from 0 to 61440. Can I give 1, 2, 3, 4 priority? No. You can assign only these values, these predefined values you can assign. So let me assign priority of 4096. So this switch 0 will be the root bridge, and this is synchronizing. And these ports 1 and fast 13 will be the root port that is currently connected directly to the root bridge. So definitely these ports will also be open. So just this port, let's transition, and it will be put into forwarding state. Only this F0 by 15. Yes, as you can see, it is up. So this is a root bridge. We can also verify with show spanning tree. Spanning tree enabled protocol is IEEE, and the priority is 4097 because 4096 plus 1 is adding VLAN 1 to it. This bridge is the root. You can see the bridge ID priority, and this gig port is the designated forwarding. Fast Ethernet is the designated port. And also alternatively, you can go to any other like this switch where you have a blocking port. Show spanning tree, and I can have the root port F0 by 13, which is in forwarding state. Cost is 19, and alternate, that is the role, and the status is blocking of the fast Ethernet 15 port, that is the block port. You can see this is the root ID, root's information, and then the bridge ID means this switches information. So this is about the IEEE spanning tree, means the traditional STP. And I can also configure RSTP. On one switch I'm configuring. The configuration will be same on others also. Just you have to give spanning tree mode. Then there is nothing like RSTP. PVST, it will be that. Per VLAN spanning tree. And if you see show spanning tree, it will be the spanning tree enabled protocol. It should now see spanning tree mode PVST. So it should be, I think, the PVST, but still it is showing IEEE because it is actually holding the information. But if I say we give spanning tree mode RPVST, I think is supported. That is why it is not showing rapid PVST, and now it should. Yes, span enabled protocol is RSTP. So this way also I've shown you one troubleshooting. Like first I gave the PVST span tree mode, but it is still showing IEEE because PVST, it is not the rapid spanning tree, it is equivalent to the normal spanning tree. So you have to use the rapid PVST for the RSTP configuration. And now RSTP works the same way. So in all switches, you have to configure this RSTP configuration. So this is the way you can configure the RSTP also. And for the MST, this is the 3 switches that is running in the GNS3, because MST you cannot configure in the packet tracer. So on one switch, I can configure the MST. I can go here and I can give spanning tree mode MST. So here you are. So MST, you can see that MST is there. And now you create some VLAN like VLAN 10, VLAN 20, VLAN 30, and VLAN 40. So these are the VLANs we have created. And now spanning tree MST configuration. So first to enable the mode and then spanning tree MST configuration, you have to give a name, that is say ICSS 123 version say 1, and instance, you have to create instance 1 VLAN 10 comma 20, or it should be in instance. Let me try again. So it is out of the spanning tree MST configuration, I think. And the revision number, let do not give the revision number, only name, because in sometimes it gives us some error. And here instance 1 in the MST configuration itself, VLAN 10 and 20, yes, and the instance 2 VLAN 30 and 40. There you go. So we have created the instances, and also if we see show spanning tree MST configuration, then you will see the instance mapping. Like name is ISIS 123, and this is actually all others are mapped to the instance 0 that is already there, and instance 1 is created which is having 10, 20, and instance 2 is 30 or 40. Now this is known for the load balancing purpose. So we can create MST for the load balancing, like we can actually have one switch that is a primary root bridge for the 10 and 20 VLAN, and another is for the secondary root bridge. So we can actually do some traffic engineering. In the MST, we can actually specify one path for VLAN 1020, another path for VLAN 3040 that we can achieve. That is the real goal for the MST. So MST is a bit higher one, and for the CCNA you have the STP and RSTP, but in CCNP level where we do the traffic engineering, so to manipulate the traffic flow, we use the MST where we actually create multiple VLANs and we group into multiple instances. This is the logic behind the spanning tree MST configuration. So this is about the configuration that I've shown you for all the protocols, STP, RSTP, and MSTP basics. And later on also, you can do the advanced parts also if you progress. So these things are very vital for your CCNA, CCNP, as well as CCI studies. And if you're actually studying for these certifications, this topic, STP, RSTP, MST, you cannot avoid, because loop prevention is a very basic for the layer 2 technologies nowadays, and it's always been. So there is an alternative of STP, MSTP, and RST. So I have another news for you. I have a contest running on with this, and I have shared a link which has 10 very easy questions. And if you can give at least 8 correct answers of these questions, you'll be eligible for a certificate. Just think about that. That certificate will be invaluable for your certification track and also for your job prospect. Because as you know, Cisco is the last word in the networking, and the CCNA, CCNP, CCI. These are the very high demand certifications in networking. And as a very senior trainer of this networking, I personally take the CCNA, CCNP courses, and I recommend everybody to go for these courses for your career advancements and to join right now. And I have another news for you. If you enroll right now, then you will get flat 10% discount. So I encourage everybody to go for it right now and enroll themselves. So that is about the STP, RSTP, MST, the design and configuration and troubleshooting topic that we have today. And I have shown you everything that is the theory and practicals of this. And I hope that it was very beneficial for your studies, and also it will help you in your job prospect as a network engineer, and you will be able to incorporate or configure the skills in your enterprise networking. So I thank you all for joining and watching this webinar once again. I will come with some new topic next time. Till then, keep studying and bye.